Assalamu alaikum wa rahmatullahi wa barakatuh. Friends, in this video we will discuss floating voltage or floating ground. Before discussing to this video, let's see the example and then we will come back. I set multimeter to AC voltage. We have earth, line and neutral. So I will check the AC voltage between line and neutral. So it is 229.7 volts. 229.7 or 8 volts, and then I will check these voltage between line and earth. It is 230.2. When we check to line to neutral, it is reading 229.8, but if we check line to earth, 230.2, it is 0.4 volt difference, 400 millivolt difference. If I check neutral to earth, so it is giving 450 millivolt. We have difference approximately 400 millivolt. When we measure voltage between earth and line, these are elevated. When we check voltage between neutral and earth, it have some difference. Why this is difference? Let's discuss. So friends, in our measurement, we find line to neutral 229.8 volts RMS AC voltage. So line to ground 230.2 volt. Neutral to ground, it is 0.4 volt RMS. Now we have to discuss this 400 millivolt, 400 to 500 millivolt, which we measured on the multimeter. We will consider it 0.4 volts. Why there is a 0.4 volt difference between neutral to ground, and what is this? If we see winding of any generator, that is 3-phase, or we can say it is a transformer of our utility transmission line which is delivered in our homes. So it have three phase winding, 1, 2 and 3. We can say line 1, line 2, line 3. And each of these 3 windings have a dead point here. That is called neutral point. And it will travel with these 3 lines. These are line and this is neutral. Neutral to one line. We will take a line to neutral voltage. We can take this winding to this winding voltage, that will call phase to phase voltage. Now we have to see some definitions. What is line? It is hot wire, or we can say it is high voltage, or we will say it is phase voltage. So it is a current carrier conductor which will drive any load. So if we make a transmission between this point to our home and we connect our load here, after this load, after driving this load, it will return to its neutral path. So what is neutral? It is a return path. We can say it is a low side. It will defined as line and it will defined as neutral. Now we have line and neutral. If we look from this point to this point, if it is 110 volt wiring, we can say we will take 110 volts at this point. That is immediate after this winding. And if it is 220, we will take 220 volt here. Now this neutral is dead point, and our current path will start from here and it will complete to the center point, that is neutral point or dead point. We have to look from this side. If we look from this point, the current is moving in this direction to the load, and there is this load which comes in series. It is a conductor. It is our transmission line, and from the electrical pole to our home, all the conductor, it have resistance. So this line, this conductor will cause to drop voltage. So this drop voltage will cause to drop a supply voltage at this point and this point between line to neutral here. If you will measure voltage here and if you will measure voltage here, there will a difference, but it will not cause to damage anything. Now if we look from this point, from the starting end of the neutral towards the dead point to the neutral point, so we have another inductor here, so it will drop voltage in this portion. So voltage from this point to this point and this point to this point will differ. Now we have this neutral line and it is connected to ground, good earth. It is for safety. Connecting neutral line, we can say low side current carrier conductor, if it is connected to ground, it is called grounding. So this will be defined as a grounding or connected to ground, because earth have a biggest electrons source in the planet. It will a reference point now. Before that, when we did not connected this grounding, it was a floating neutral, so that it was not having any reference from this point to earth. But when we connect a conductor and we make a grounding, then we have this reference. This ground is now reference point. If we measure voltage from this point to this point, it will 0 volt. If we measure voltage between this reference point to this reference point, it will become, we can say, 220 volt. I will not discuss this because my utility line is 240 volt. So I am receiving, sometime I am receiving 230 volt. So as an ideal condition, from this point to this point, I will take 220 volt. So this voltage must be here 220 volt. But in this condition, we have from this point, from this reference point to this point, we have this inductor. It have some resistance, it have some XL. Why XL? Because now it is working in AC line. We have AC line, so in AC line any conductor will work as an inductor as well. So we have XL. So this point to this point, this conductor will work as a load. Then we have RL. And after that we have another inductor, that is RXL, that is for neutral. This was for line. So we have two resistors in this path, the first one and the second one, and then we have third resistor here in the center. Now we have to consider this point. This point is very close to ground, so it is ground. So from this point to this point it is 0. Now we have to consider point A, point B, point C. Point A is starting point from here, so we will take a full voltage here. But from this point to this point, this is point B, so point B will different from this point. Why? We have this resistance, so these voltage are different and we will not consider it. Then we have another point, that is point C. After load, in the low line, in the return line, there will a voltage drop from this point to this point, and we have this 0.4 volt RMS in my condition, 0.4 volts. Then we have point A, B, C, D. D point is this point, so point D is close to 0, but From this end to this end we have this inductor. So 0.4 volt, why it is 0.4 volt difference in my condition? Because I have just only 300 meters distance from my lab to the power transformer. In ideal condition or in routine, it is acceptable 1.5 volt to 3 volt, and in some conditions we can say it is 5 volt. So this is in standard IEC standard, that this is acceptable range. Above than this it is difficult, it will a problem. What are the parameters if these voltage will increase, and what are these voltage? 0.4 volt in my condition, these are floating voltage with respect to this reference. In ideal condition, if we have 0 volt here, the same neutral line is here, so it must be 0 volt. But no, if we have a good ground here, as I have in my workshop a good ground, that is good earth, so that if we measure voltage from this point to this point that we are discussing in this equivalent circuit, it is 0.4 volt. So these voltage 0.4 volt difference, why is difference? The first parameter which we discussed, conductor resistance. The second parameter, we have earth here and we have earth here. From this point to this point, the earth resistance, and from our good earth to the ground point there is a earth resistance. So from this point, from this grounding point to the earth, we have this resistance and this resistance, and between the earth there is a resistance, so earth resistance, the second parameter. Then the third parameter, that is EMI, RFI, lightning. So these different parameters will cause to raise this voltage with respect to reference point, that is here, and this raised voltage level is called floating voltage. That it have a resistance, it have a difference between the reference point. In ideal condition the reference point is same, earth. If here is 0 volt, here must be 0 volt, but these parameters will cause to float this voltage with respect to the reference point. In our normal life, what is the floating voltage and why it is effective, and what is the problem in this floating voltage? To understand the effect of floating voltage, we have to consider, I have different type of loads. The first load I will example, that is 2-pin load. That's a very normal routine use hot air gun, it is in our homes. So we have this 2-pin plug. Current will enter in one line and it will return back to the second line and it will complete its path. It is our first 2-pin plug, and then we will see its effect. And then we have this 3-pin plug, 1, 2 and 3, line, neutral and earth. And here we have line, neutral and earth. What is difference in this load and this load? This have just only 2 wires. It have a non-metallic, so it is a plastic body. It have a double safety. Why? It have insulation. The wire have insulation. When it will enter in the load, it is insulated and its body is insulated. But in this load we have a metallic body, and in this power supply it is using 3 wire system, 1, 2 and 3, line and neutral to our load in this condition. And this end is connected to earth as well, that is neutral grounded. We have grounded, neutral and line. So the current will start from this end, it will reach in the load and it will complete its path to the return line. If it have some leakage, some fault, if any wire is short circuit from inside, so we have second insulation, that is outer body, so it will not cause to damage anything. If I am standing on this earth, that is reference point, so if I touch this body, it will not give an electrical shock because we have insulation. So it is insulated, it is safe. Either this end will touch to body or this end will touch to body in this first condition. So it is using two wire system. But in this condition, in case of any failure, in this condition we have three wires. Two wires are going directly to drive the load, line and neutral, brown and blue wire. So these two wires are entering in the load and it will drive all the circuit, it will work normal. And here we have class Y capacitors that are to eliminate the noises, class Y capacitors. Now in this condition, class X capacitor here, and from here to here we have class Y capacitor that is inside this power supply. Due to any problem, due to any failure, due to any malfunction, this line will touch to the body because we have a dead metal. Why dead metal? In normal condition it is not supplied to any voltage, so ideally there should no voltage, but in normal condition it is dead. Okay, I will take another example. I have a pedestal fan, it have stator winding and its body is metal body, it is on the ground. If this end will leak, if this end of the winding, stator winding will leak and it will touch to the core, its insulation paper gets leak, so this will touch to the body. In our this case, when at IEC standards, if it is taking 3 volt, so 3 volt appear in the body. That is not dangerous in this condition. And if someone will stand on the same earth and he will touch the body, so he will take 3 volt shock. That is not dangerous in normal condition, so this 3 volt are acceptable. But in second condition, if this end of the winding will short with the core, so the phase voltage, the line voltage, the hot wire will give a leakage in the body. So we have winding two ends. It is the entrance. When current is entering, if we have a leak from this point, so we will take, if it is 220 volt with line to neutral or line to ground, so it will give a 220 volt leakage in the body. So if our pedestal fan have metallic body, so its body will become as a live wire. So 220 volt will cause to give a severe shock to anyone who will touch this. Similar position. In case of failure of this power supply, if line will enter to the chassis due to these filter capacitors, due to anything, due to any component failure, we can say this body will take line voltage and it is dangerous. If it is a casing of a computer that have a metallic body, so this metallic body will become prominent to the line voltage. In the second condition, if we have floating voltage that are 0.4 volt here. In normal condition, if it can go to 5 volt, that is acceptable. If this our home is far away from this utility transformer, so it can raise more voltage level. So if it is above 16 volt, it is dangerous. So for a safety purpose, this chassis external body that is connected to a good earth, it is dead metal. It is in normal conditions, it is not a current carrier component. It has no current, so it is a dead metal. So when we connect a dead metal to earth point, it is called earthing. We have two definitions here. When we connect a low side current carrier, that is called neutral point. Either it is high line and it is return line, but it is a circuit. If we forget this ground, it is a current path. So we are grounding this end. So it is neutral line, that is dead point of the 3 coils. If we connect neutral line low side current carrier conductor to the ground, it is called grounding. And if we connect a dead metal, that is chassis of this power supply or the stand of our pedestal fan of any washing machine which have metallic body, when we connect that body to earth, it is called earthing. In this condition, the earth is directly involved in the return path, but here it is for safety. In both conditions, if we have a leakage here, that is floating voltage 1.5 volt to 3 volt, so these will grounded and the body will save. And in second condition, 220 volt, these are short or these have leakage to the body, so these will grounded directly. It will cause to burn the fuse, blow the fuse, or it will cause to drop the circuit breaker due to overcurrent. Why? In that case, we are connecting from this end directly to the earth point. We will give a easy path to the line voltage to enter in the ground to protect the human body. I have line and neutral, and I have any load. For example, I have this Xbox power supply. Here we have these 2 lines, 1 and 2. It is 2 lines. As I discussed, if we have a metallic body, then it will use 3 wires. In this condition, in our computer power supply, the metal body, it is using 3 wires, line, neutral and earth. And here it is using just only 2 wires. Why? Because in Xbox power supply we have plastic body. It is insulated. It have double safety. Current will enter. Then we have here a transformer. This transformer will provide isolation. After this circuit we have isolation. In this condition we have 3 wires. One is connected to the chassis. We have line and neutral. And after this transformer we have output here. That is the secondary side of this power supply. So in our computer power supply, the chassis that is connected to earth point. Now we have this transformer and we have output. This neutral line, either it is connected from here to the earth point, or either it is connected here to the earth point, that will the same. So this line is to eliminate the noises. When the noises are removed, we have a reference point between earth and neutral, earth and line. But in the output side, we have just only this current flow path. Either it is a neutral point, we have another winding. that is connected to this one end will connected to the same point, and we have taken 5 volt. Here I am taking 12 volt, here I am taking 5 volt. So if we measure voltage between this neutral to this 12 volt, now it have very high resistance. Why? We have isolation. So these voltage have their own path. After driving the load, all the circuits will come to their reference point. Its reference point is this one, and this circuit have reference point here. So when we have a high resistance between any earth and any source, a return line or anything, so that is the floating voltage. Now we will not find anything, because if we check voltage from here to here, it have 12 volt. From here to here we have 5 volt. So this floating voltage are separate. So if anyone will touch to the neutral of this side, it is safe, because we have a separate source, and in this condition we will not take a shock. So in electronic circuits, to give a separate current circulation, current path, this circuit is floating circuit. Why? Because it have no connection, it have no concern with the reference point, that is the earth point. So earthing point is used to protect the equipment, protect the human body from these floating voltage, which are measured between the reference point, that is the earth point. So for safety purpose, a safety ground must be connected, especially in those appliances which have a metal body and that are exposed to touch anything, any place, any metal part. So it must be grounded, and we must use a earthing point for safety. Friends, I hope so this video is informative for you. If it is informative, hit the like button. If you have any question, kindly let me know in the comment box. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.